our experimental methods research review. And we finished off with experimental condition or experimental group and control group, so make sure you review those. And one of the things that we need to know about these two groups, the experimental and control group, is at the end of an experiment, we compare the scores on some test or performance between the experimental group and the control group together. We compare the dependent variables, the mean scores. So if we had 50 in one group, 50 in the other group, and they had a mean score on Blonde is More Fun survey out of 7 points, and the experimental group, who all had blonde hair, scored a 4.6, and the control group scored a 3.4 on average, we compare those two groups together to see if they're statistically significant. We'll talk about that in a little bit. So internal validity. Validity just means that the test was valid. It measures what it is supposed to be measuring. So internal validity refers to the extent to which we can be confident that the IV caused the change in the DV. There weren't some other odd explanations. The fewer the explanations you have, the more internal validity there is between the two groups. If there's a difference between the two groups and the only explanation you have is that the IV caused the difference in the DV, then there's internal validity. Random assignment, we already talked about. Excuse me. We went a little bit too far here, but control techniques. So what can we do in the control techniques? Well, we can we use the control group. Remember, that's the comparison group, just to see if the experimental group was different than what we would expect to have happen. The placebo is something we can give the control group, so they're getting some condition, but the placebo should have no effect. It's inert. It means it's neutral. If we're giving drugs, we call it a sugar pill. But the placebo effect occurs when the control group subjects actually experience a difference, even though they shouldn't, just based on their expectations. So if they think they're getting a reading program that will improve their reading might improve even though the program is bogus. If a subject, an experienced drinker, thinks they're getting alcohol because a beverage smells and tastes like alcohol, but it doesn't have any alcohol in it, might experience some of the loss in ability to react. They might shorten their reaction time, might get longer. How do we control this? Well, we blind people. Blinding means that the subjects or the experimenters don't really know who they're dealing with, so they don't have preconceived expectations. Single blinding is when the experimenter doesn't know which group they're dealing with. Somebody has to, of course, but not the person who's giving instructions or not the person who's assisting the subjects. So their biases don't enhance performance somehow. Double blinding means the subjects don't know if they're in the experimental group or control group, and the experimenter doesn't know if they're in the experimental or control group. So biases and expectations minimize. Some problems that we see with experimental designs are subject effects or biases. So if we don't have a random sample, we could have biases because people in one group might be similar to each other, and that's why that's why they act a certain way. So the subject bias, if their expectations taint the results, though that can be subject bias. Demand characteristics are characteristics demanded of the subject. So if I think I am supposed to have a better memory, I may actually try really harder than I normally would have. So I live up to the characteristics demanded of me. Experimenter biases mean that the expectations of the experimenter might influence the performance of the experimental group. Confounding variables and extraneous variables. Gosh, if there was a multiple choice test, I know one of these would be on there. But confounding, any variable is something that could have an effect. A confounding variable means that if there's a difference between the results in the experimental control group It could be due to differences carried in. Um, be, it could be because the experimenter carried in problems in the experiment. It's a design flaw. It's a construction flaw. So confounding variables could be time of day. We tested all the experimental group in the morning and all the control group in the afternoon, and there was a difference between their scores. But maybe we perform differently in the morning versus the afternoon. It could be location. One room might have better lighting. One room might be noisier. One room might be hotter or colder. So confounding variables are construction flaws. It's the experimenter's fault. And when you take experimental psychology, you'll see how difficult that can be. Extra variables are extraneous variables that they're carried in with the subjects when they walk in. Fatigue, ability, experiences. We can't test for all that, but some of those factors could influence the results. So if somebody's already a better reader, they already have better math skills, they already have more anxiety. So in order to avoid that, we'll talk about that. You should be able to guess what we could use to avoid that flaw. It's one of the most powerful control tools we have. So a quasi-experimental design is basically very similar to everything in an experiment or in a true experiment, but we lose control because we either didn't have a random sample or we didn't use a random assignment. So it's sort of like an experiment. We just use a convenient sample, okay? So between subjects designs, that is a classic experiment where you have different people in the experimental control group, so we compare between different subjects. A within subjects design is a pre-test, post-test. So we give you a test at the beginning of the quarter to test your math skills. We give you a test at the end of the quarter to check your math growth and to see if there's an improvement in scores or abilities. So you are your own experimental control group. We'll talk a little bit about ethics here. Remember the IRB, the Institutional Review Board, has make a decision if the experiment could do any harm. So do no harm is the most important experimental method. Think of the Tuskegee Airmen study. They infected people with syphilis and they let people, to see if the medicine worked, but they let some people just degenerate and get sicker and sicker without letting them know. We should have limited deception, which means we can tell some untruths, but not enough that people would make a poor decision for themselves. So we have to give them enough information so they can make a good decision for themselves. So we have to avoid deception, but we can lie about what we're measuring in the DV, for example. Also, let me get back up here, sorry. Informed consent, we can't tell them everything about the experiment, what our expectations are, because then it'll lead to demand characteristics. But we do have to give them enough information about what they'll be doing so they can make a decision whether or not they want to do it or whether or not it would be dangerous. So let's say somebody's pregnant or somebody's on medication, and we have to tell them you may or you may not be drinking a beverage with alcohol in it, so they can say, oh, I can't be drinking any alcohol. We can't just say to them, oh, you're going to drink a beverage and it might have an effect on you, but there's no alcohol. We can't do that because they could get hurt and we don't want to do any harm. Freedom from coercion is freedom from force, freedom from pressure, freedom from fear of retribution. So think about the Zimbardo test here. We have to preserve confidentiality, so none of the information can come back to harm the subjects in any way. And we do have to debrief afterwards. We have to give them enough information so they know what the purpose of the study was, and later on we could talk about results. Plagiarizing, we already know. Ethics with animals, remember the ABCs. This was determined by the APA. The A stands for research is absolutely necessary and beneficial to either humankind or the animals themselves. Remember when we developed rabies shots, we had to inject cats and dogs with rabies, and they got pretty sick and some of them died. But in the long run, it was considered absolutely necessary because it did help animals and humans in the future. We have to limit suffering. So It has to be absolutely necessary and beneficial, and we have to give um, enough comfort or consistent comfort, which could be food and shelter and comfort and socializing and freedom from pain when possible. And if we have to euthanize the animals, we have to do it very um, swiftly and with as much care as possible in a humane way. Whistleblowing is one mechanism to help discover misconduct in research, and there's other things we can look at. So that'll be it for this one. It was short. Review your experimental packets. There are some other things in there that we didn't get to talk about, like blinding and some things like that. So remember our most powerful control tools: random sampling and random assignment and blinding. Okay, random sample, random assignment, blinding. That's it for now. We'll come back with some statistics in a little bit.